Okay, let's get started. This is chapter 10, using ratios and proportions or dimensional analysis to solve pharmacy calculations. So basically what this chapter is all about is ratio and proportions. Ratios are used to make comparisons between two things. When you express ratios in words, you use the word to. For example, you say the ratio of something to something else. Okay, a ratio can be written in several different ways: as a fraction, using the word to, or with a colon. So it can be written like this, or like this. Okay, that's a fraction, using the word to. Okay, or with a colon, the two dots. Okay, so all of this means the same thing. Okay. Equal ratios with two different ratios that may include different numbers when expressed as fractions, but can be reduced to the same fraction. So to find an equal ratio, you multiply or divide each term in the ratio by the same number, but not 0. Okay, so let's just get started into some of the problems that I was told you guys needed help with. All right, let's find them first. All right, so basically, number 1, it's asking for 5/8 equals 25 over 40. They want to know what the extremes are, okay, the extremes, and the means, okay. So in this case, the extremes would be 5 and 40, okay, and the means would be 8 and 25, okay, 5 and 40, 8 and 25, 8 and 25, okay. So basically what you're doing is crisscrossing. Okay, so now that's number 1 in the chapter. Number 2 is asking, fill in the blank for each pair of ratios to form a proportion. So a proportion is this to this, okay, this to this. So in this case, you have 2/3 equals and 4 over what would make it a match. Okay, so all you have to do is you create this question mark into an X, and you translate it as 2x equals 12, and in this case you want to isolate the x, right? And your answer is 6. So x would equal 6 in this case. Okay, if we move on to number 3, you have 5/7, all right, and 15 over what would make this a proportion. So you get 5x equals 105, sorry, right? 7 times 15. Is 105, yeah. And then you you isolate the x, okay, in order to get the x on its own so you can figure out what it means, right? So x would be 21 divided by 5, 21, yes. Okay, so that's what you do between questions 2 and 6. Okay, then between 7 and 15, it's a little opposite, but it's still the same thing. Okay, number 7 in chapter 10, pharmacy calculations, you have blank, which would be x, right, over 3, and I always say equals to, but it's and 4 over 6. Okay. In this case, you would get 6x, and 4 times 3 equals 12, and you isolate your x, and you get 2. In this case, you get 2. 6 goes into 12 2 times. Okay, same difference. And let's do one more just for shits and giggles. Okay, x, which is the blank, number 8, over 8, and 3 over 24. Whatever you don't know becomes the x. Okay, and then you crisscross. 24x equals 8 times 3, which would be 24. Okay. When you divide by the number, it always becomes 1. Okay. So x equals 1. And that is the same thing you do all the way down up until question number 19. Okay. I'll be back with some more examples as far as pharmaceutical examples.